Welcome. What we're going to learn in this video is how to provision virtual machines inside of GCP using Terraform. So you'll see how to create a Google Cloud virtual machine and some of the real basics of working with Google Cloud and Terraform. Now, what we're not going to cover is the absolute basics of the Terraform workflow. If you've never seen Terraform before, if you've never used it, if you don't know what it is, how it works, then I recommend watching the Terraform Basics video, which is linked in the description below. You can always come back here after you've watched that. It's only 20 minutes, and it'll give you that grounded introduction into Terraform. So let's begin. Now, the first thing that we need to do whenever we want to use a cloud with Terraform is we need to configure the provider. So the provider is the interface between the configuration, the HCL Terraform configuration, and the cloud's API. So you define your resources in Terraform configuration. That then is interpreted by the provider and turned into API calls. Now for Google Cloud, what we want to do is we want to use the Google Cloud provider. If you look at my screen here, I've got the documentation page for the Google Cloud provider. And what we want to do is we want to add this to our config. Now, over here, there's a little button which says Use Provider. And the configuration shown here is exactly what we need. So let's copy this and let's add it into our config. So I'm just going to add this to the file main.tf here in my example repo. And let's have a look at what's going on with this. So first thing, you've got this Terraform stanza. Now, the Terraform stanza allows you to configure things like required providers. And the required provider in our instance is the Google provider. So why do we mark a provider as required? Why are we specifying the version? Well, what we want to do is we want to pin a particular provider which is distributed as an external plugin to Terraform to a specific version. And the reason we want to pin it to a specific version is that we want to ensure that the configuration we write is always going to be compatible with that version of the provider. Now, you can always update things whenever you want, but it's best to do that when it's within your control. So for example, the virtual machine resource that we're going to create, somebody might decide that there needs to be a new attribute or an attribute changed with that resource. So that could break your configuration if you're not pinning to a specific version. So it's not an essential concept, but it's an important one. And I think something you should get used to as you're kind of going and learning Terraform. So we're going to do that. So we're pinning to version 6.01. Now, what we're also adding is this provider block. Now, the provider block allows you to do things like configure certain elements of the Google provider. You can do things like set the project, you can do things like set the credentials, and a number of different things. Let's have a look at the documentation and see what you can actually configure in this block. So if we look at these example blocks here, you can see that some of the configuration options are the project, the region, and the zone. So if we scroll down a little bit, you'll see that you can set these as environment variables. If we just keep going, we should be able to see it. Here we go. So for example, the project, which is an optional configuration for that provider block, can also be set with the environment variable Google Project or Google Cloud Project or G Cloud Project. And the same goes for the region. So you have a number of different options there. Now, I think the most important thing for you is the credentials, because in order to interact with Google, what we need to do is we need to be able to authenticate against Google's Cloud's API. And to do that, we have to specify the credentials. A number of different ways that we can do that authentication. We can actually provide a service account JSON, we can provide a key file, or we can actually just use the Google CLI and authenticate that way. In this video, we're going to look at how to use a service account. And to do that, then what we want to do is we want to set the value of that service account or the JSON file that is returned from creating a service account key, and we want to set that value into the environment variable Google credentials. The reason that we don't want to set this hard-coded into the provider block is because we want to keep that separate. We want to have the configuration stored outside of our Terraform configuration. We don't want to mix auth config and Terraform config, because if we accidentally commit our Terraform config to a public GitHub repo or another location and it has the credentials inside, then that gives somebody the opportunity to steal them. So we're going to keep those separate, and environment variables is quite a nice way to do it. So let's have a look at that. Let's see how we can create the credentials so we can then authenticate our provider. So I'm just over in my Google Cloud console here, and I've already logged in. So to create some credentials for Terraform, what I'm going to do is create a new service account. So if I just go up here and type in service accounts, then we can get to the service account section. And what we're going to do is we're going to create a brand new service account. So I'm just going to click the Create Service Account button. I'm going to give it a name, and I'm going to call my service account Terraform. The description I'm just going to leave blank, and then I am going to create that, and I have to assign it some permissions. So the permissions that I need to assign the service account will enable it to create the resources inside of Google Cloud. So you can be very granular with this. You can specify only certain GCP APIs are able to be used. I'm going to do this with a very sort of permissive setup just for the example here. So I'm going to use the basic, and I'm just specifying owner. So I'm just going to hit create here. And then I'm not going to grant any user access. I can just hit done. And then we have that service account there. Now the service account is fine, but we need to generate keys so that we can authenticate with that service account. So if I just click on the service account and I go over to keys, then what I can do is I can click the add key. Now I'm going to create a new key, and I'm going to use the JSON format, which is the recommended format. Now, when I create that, what it's going to do is it just downloads it into my downloads folder of my computer. Let's take a look at that account. So if we take a look at this file, and I'm showing you this on my screen, even though you're thinking, well, you just leaked your credentials to the entire of the internet. I will have deleted this by the time this video goes out, so we should be pretty much safe there. But you can see that it is a JSON file. You can see it is also multi-line. Now, in order to set that into an environment variables, we need to convert this into a single line. And the way that we're going to do that is we're going to run this command here. So the command I'm just going to run, all I'm doing is I'm just catting that file and then I'm piping it into TR. And I'm just going to remove any new lines and replace them with a space. So if I now press that, and then you can see, then we get this kind of output here. So the output now is in a single line. And what I can do with this is I can take this and then I can copy that into a location where I can set it to an environment variable. I'm going to take this and I'm going to put this into my 1Password because that's where I'm going to use to store my credentials. You can obviously do whatever you use to kind of store your secrets, but I do recommend make sure that these credentials never leak. They're never in a file that's available to where you could accidentally upload it to GitLab, because you will be having a very bad day. So the minimum that we need in terms of setting the provider configuration is the Google credentials and the Google project. So I'm going to set these environment variables. So what I've got on my screen here is a NVARC, an environment script that I use automatically with dirn whenever I enter a folder on my computer. Now, you could store these in your bash profile or wherever you want, but I find this is a convenient way when I'm working with multiple projects. So I'm going to set that Google credentials and I'm going to set that project. Now, in order to get those credentials, what I'm doing is I'm actually using the 1Password CLI. The 1Password CLI, you do not have to use this. I find it very convenient. It's a great way to kind of manage my secrets and my passwords for my computer. So I've just got a little script here which does that. And all it's going to do here is I'm using the 1Password CLI, I'm fetching those values and I'm setting those to an environment variable. Now I could set this completely manually. So if I go over to 1Password, let me just grab my project ID and I'll show you. So I could just set it like this. You know, there is no reason at all that I have to use 1Password. I can just hard code those values. It's entirely up to you, but keeping things separate, keeping things secure should be something that you think about all of the time. And I find 1Password really useful for this. So these are set. Let's continue. Let's now have a look at creating that virtual machine. Back over at the documentation. The resource that we're going to create is Google Compute Instance, and this is going to allow us to create that VM inside of Google. Now, I'm just going to use the example here that's in the Terraform documentation. This is pretty much all I need. I'm going to make a few little modifications to it, but let's just do this. First things first, I'm just going to copy all of this here, and I'm going to paste it into my configuration. Go over to my configuration, and I'm pasting it in here. Now I'm putting this into a file vm.tf. Previously, I was putting things into main.tf. Terraform doesn't mind. As long as all of these files are in the same folder, Terraform parses them and it kind of works out the order automatically. You don't have to put specific resources into specific files. You can organize things how you find the easiest for you. I find keeping things a little bit separate is the easiest way, which is why I've got my main file and I've got my VM file for creating my VM. So here we've got the Google service account. So we need to create a service account and assign that to the VM. So let's just rename these. I'm just going to call this Open Web UI, and then I'm going to rename the account ID Open Web UI. Now the Google Compute instance, I'm going to do the same thing, Open Web UI. Now I want to note something here. The name here where I'm changing in the Terraform configuration is not going to be the name that the resource will be created inside of Google Cloud. That's actually going to be using the name parameter that you see there on line 7. Terraform uses the resource names when you're linking things together. So it's something that to enable the linking in Terraform, not necessarily for the resource naming itself. So I'm just going to call this Open Web UI anyway. And I want to change this to an N2 standard 4, give it a little bit more memory. So the zone I want to create this in is going to be in Europe. I want to change this, so I'm just going to paste this in here. And I'm putting this into Europe West 1B. And that's the zone which is closest to me. The tags, these are going to be tags which are attributed to the machine. We can kind of leave these as they are right now. And then we can look down at the boot disk. Again, let's kind of leave this for now, but this is going to be the base image that we're going to use to create our virtual machine from. And this is Debian 11. We can optionally add an additional disk. Remove that because we don't need it. Network interface, we're going to leave the same. Metadata, again, that's data which is going to be added to the virtual machine. So whenever you're searching inside of the cloud console, and the startup script. Now the startup script we're going to come back to a little bit later. So let's just remove that for now. And then let's look at our service account. So our service account is a service account we're going to attach to the virtual machine. Let's have a look at this. Now, what I'm doing here is Open Web UI. I'm just changing the name. So I am referencing the service account that I created at the top of my configuration here, down here. Now, the reason that I'm creating this reference in this way is that Terraform now understands that it has to create the Google service account before it creates the virtual machine. So it doesn't matter which order I define the resources in my configuration file. It's the dependencies that are declared in this way using this interpolation that helps Terraform understand the order of resources that need to be created and destroyed. And it's a really nice way because, again, that means I don't need to worry about the kind of the parsing order or which file it's in or anything like that. Terraform can just figure it out. This is pretty much all we need to create the virtual machine. But before we do, I want to make one small change, and that relates to the image here. So I want to show you a way where you can kind of make this a little bit more dynamic, how I can specify which image that I want to use. And the way to do that is to introduce a concept called a data source. A data source in Terraform is, you can think of it as a read-only resource. So it provides the capability for things like where Terraform can query Google's APIs, and in our instance where we can retrieve a list of virtual machines. And then we can get those settings which we can use inside of our Google Compute instance. Let's have a look at the data source for this. So the data source we're going to use is this one here. It's called Google Compute Image. Now what we can do with this, we can specify the family and we can specify a project, and we can then automatically get the correct image name. So the project we want to use and the family is actually Debian. So the Debian 11 example is exactly right here. But let's just quickly have a look at all of the different images available. Because if you go over to your Google Cloud Console and you go over to the images section, then you'll see that there are a huge number of public images. So for example, let's just do a quick search here, and we're going to search for Debian. And we'll see, there's a number of different images. In addition to the kind of the basic Debian images, there are also the deep learning images, which we're actually going to use later because the deep learning images have got things like the NVIDIA GPU drivers and certain different bits and pieces already set up for us. So that's great. But we're just going to use that basic. We can just use Debian. Let's get that into our configuration and we'll see how we can link it up. So I'm just adding it in my config here. And again, it doesn't matter where I put it. I'm just putting it at the top. I'm going to call it Debian. The family is Debian 11. That's correct. And the project is Debian Cloud. That's exactly what we want. Now to be able to use the value of this, what we can do is we can actually reference it from within our boot disk. So rather than this hard-coded value here, what I'm going to do is I'm going to change this to be data.google cloud image self link. And what this is going to do is this is going to reference that data element. So the data element is going to query Google Cloud. It's going to get me the latest Debian 11 image. And then the value of that I'm going to plug into here, which will be what's used to create my virtual machine. I'm going to make one more change, and that is I'm just going to get rid of the labels because I don't need those for now. And I'm going to change the size. What I'm going to do is I just want to change the size of the base disk of my virtual machine. I'm going to set this to 200 gig because I think by default it's something like 20 gig or so. We're going to kind of have something a little bit beefier. So we set that there. Everything is now pretty much good. What we can now do is run an init, a plan, and an apply, and that will create our resources. So let's go do that. To add a new provider or a module or anything like that to your Terraform configuration, you need to run the Terraform Init command. And the Terraform Init command is going to download those providers. So you can see there, it's downloading the provider, which is an external plugin, and it's going to store it locally on my disk. And everything's downloaded and got there. So let's run a plan now. Let's see what changes would be made if we actually applied our configuration. Terraform plan. And then when we run a plan, Terraform is checking our configuration for any validation errors, and it's going to tell us it's going to make changes. So the changes it says it's going to make, it's going to add 2 resources, and we can see the details of those. So the 2 resources are the service account that we defined and also that virtual machine. Now you can see here that some of the values, we know what they are, some we don't. They're only known after the resource has been created. Because after the resource has been created, the Google API is going to provide information to Terraform, such as the IP address and things like that, that are only known once the VM actually exists. So we can see some of those things there. Now, let's run that apply, and then let's create those resources, and then let's see the outputs again. Run Terraform apply. And Terraform apply is actually going to give me the plan again, just as a quick sanity check. But now it's saying, am I happy? So I'm going to answer yes, because I am. It's now going and it's creating those resources. So Terraform is interacting with the Google API, and it's automating that creation of the virtual machine for me. And this takes a little while to create. So let's just wait for this to finish. And there it's done. I mean, that was actually pretty quick, 18 seconds or so. We can't really complain about that. But let's look in the Google console, and we should be able to also see that virtual machine. I'm just going to search for virtual machine. So I'm clicking VM instances, and there you go. There you can see the virtual machine that was created. So Open Web UI, that was what it was called. You can see the internal IP, the external IP, and all of those bits and pieces. If we go back over to Terraform, this configuration that I've written here, this resource, Google Compute instance, when I ran that Terraform apply, that's actually gone and created those resources inside of Google Cloud, which we can see there. So this is awesome. Now, let's look at this a little bit further, because what I want to be able to do is I want to be able to log into this virtual machine. So how do I SSH into it? So to SSH into the virtual machine, I've got to do 2 things. One, I have to configure the firewall to allow port 22 to allow access to the machine. And the second thing is I need to add my public key to the authorized host, so that when I attempt to log in using SSH, the machine will let me. So to do that, what I'm going to do is I need to add my key to the metadata section of the virtual machine. So we see here that metadata is referenced in the docs, and it says that it's key value pairs to make available to the instance. So we need to go over to the Google Cloud docs over here to kind of see the kind of the detail on that. But again, if I scroll down, what I will see, here we go, SSH keys. So there is a key within metadata called SSH keys. And what I'm going to do is I need to add my public key to this collection. So how do I go about doing that? Well, let's take a look. So I've found the metadata section inside of my configuration. And what I'm going to do here is add those keys. So one of the keys is SSH-keys. And this is what we're going to use. So it takes a string. So we want the name of the user, and the user will be Open Web UI. And then what we want is the key as a string. So the key is a string. How do we pick that up? Well, what we need to do is we need to look at another little technique of Terraform, and these are functions. Let's have a look at functions. Terraform's got a huge number of functions. You can do things like get the maximum value of a list of integers. You've got other numeric functions, such as being able to get the absolute value, logarithmic values. And then we can have things like string functions, which will allow you to test whether something ends with a value, whether you want to split a value based on a thing like such as a comma separated list of values. And we have things like being able to kind of trim and clean up string values. There are a huge number, and I recommend that you check out all of those because they are incredibly useful. In order to be able to get our public key, what we're going to do is we're going to use a file system function. And the file system function that we're going to use is called file. So what file does is it's going to load the contents of a file at a given path, and it's going to just return that as a string. And that's exactly the format that we want for the metadata section inside of our Google Cloud resource. Let's just look at that. So we're using this file function. Now, let's have a look here. We're using this $curly bracket. The reason that we're using the $curly bracket is because we're using interpolation. So we're telling Terraform that inside of this string contains a Terraform function, and the Terraform function called file. So the path is going to be the path to the public part of our public-private key setup, our SSH key. If you don't have an SSH key, there's a number of guides on the internet on how to create one. I've already got a public part of my SSH key, and that actually is at temp ID RSA pub. So that's where we're gonna load the file from. And then we're gonna sort of just specifying the name for the key of Open Web UI. So that's all I need to do to add the key to the machine's authorized hosts. What about the firewall? Because we mentioned that we need to set the firewall for the virtual machine in order to allow port 22, the SSH access. Let's see how we do that. So we're going to add a new resource. Let's add the new resource here, and we're adding SSH. So we're going to add a Google Compute firewall. We're just giving it the name SSH access. We're specifying the network. Now I'm just using the default network for my virtual machine, so it's okay to specify here the protocol on the port. The protocol is going to be TCP, and the port that I want to open is 22. So the target tags, this relates to a set of virtual machine targets to which this firewall will apply. So we're saying that if a virtual machine has the target tag as a tag of SSH, then this firewall rule will be applied to it. And then the range, this is the input range. We're going to allow access from anywhere. So we've set that. What we need to do is we need to make sure that that tag is also on our virtual machine. So we're going to go up to our virtual machine, and we're just going to change our tags here. So we're going to change this, and we're just adding SSH. So we've now got the tag added there, and we also have the firewall rule, which is kind of referencing that tag. So this is awesome. This is all we need to do. So now what we can do is, again, we can run that Terraform apply, and we should see the changes. So let's just run that Terraform apply. Just Terraform apply. So Terraform now is going to look at the resources which exist. It's going to look at the resources that have been newly defined, and it's going to tell me that it needs to make some changes. So Terraform here is telling me that there's one resource to be added. And if we scroll up, that is our firewall configuration. And it's telling me that one resource can be updated. And the resource that can be updated, well, that's our Google Compute instance. So let's look at the changes that are going to be made to that. Well, we're adding the SSH key, and you can see there the value. So there's my public key. It's been loaded using that file function. And you can see that we're changing the tags. So we're getting rid of bar and foo, and we're adding SSH, which will enable us to have that firewall rule apply. And we're not destroying anything. So let's go ahead. Let's answer yes to this. Those changes will be made, and then we should be able to log into the machine. Now, I'm saying I should be able to log into the virtual machine, but I don't actually know what the IP address is. So I could go over to my console, and I could copy the external IP from here, or I could actually get it from the resource itself. So let's look at another Terraform configuration called output. So an output allows me to retrieve a particular property of a resource inside my Terraform configuration and write it out whenever I run Terraform plan or apply. So let's do this. So we're just going to define that output, and I'm specifying it here. So output, it's called public IP. So that's the name of the output that I'm going to create. And then I'm setting a value. So I'm using that interpolation syntax, and I'm saying the Google Compute instance called Open Web UI. And what I want to get is the network interface, the first network interface. So I'm using this accessor there because network interface is actually a list. And I want to get the access config. Access config is also a list. So I'm specifying I want the first one, and then I want NAT IP. So this is all documented inside of the documentation. So if we go over there and we just scroll down, and if we just scroll down a little bit till we find the network interface block, you can see all of those properties. Now, I'm not setting these because these are actually being set whenever the resource has been created, but I can reference them. And that's what I'm doing here. So let me save this. And then let's run a Terraform apply to create that output variable. Terraform apply. And now this should only take a second because Terraform is going to do a quick check, and then it's going to create that output variable. And there we go. So the public IP now we have out in our Terraform configuration. So whenever I run that Terraform apply, I will see those values. There's a nice little trick that I can do with output variables though. And if I clear this, and if I run Terraform output, you can also get those values. So by specifying Terraform output, I'll get all of the values. If I specify a very specific value, so public IP, I'll just get that one value. And then in addition to that, if you look at this, what it's doing is it's wrapping that in a string. So we're adding these quotations. And that's because Terraform is saying, well, the output variable is a string, so it's adding that quotation. If I don't want those quotations, I'm just going to add an additional flag, and I'm adding raw, and you'll see that I only get that basic value. So why is this useful? Well, it's useful because I've got a little trick that I can show you. Because I can actually SSH into the machine, and then I can get the public IP automatically from my Terraform configuration using a little subshell. Let's see this. So we're going to run this command here. So we're running SSH, we're running the name, so Open Web UI, that's the user that I've created. And then I'm running a subshell. And what I'm doing is I'm using that Terraform output command that you just saw to get the public IP. Now, if I press enter there, all of that's going to kind of run. So SSH, the subshell is going to get the IP address. That's going to be passed into the SSH command. And you can see we've now got access to our virtual machine. So I'm just on the VM there. I've got my user Open Web UI and everything's good. Well, it's kind of good. What we've created is a virtual machine. We've kind of seen how we can spin that up and how we can configure things like the access for the firewall, but we haven't seen how to provision an application to it. And we're going to do that next. But before we do, let's just see how easy it is to remove that VM and how I can clean up after myself. So I'm going to use a new command, and I'm using the command Terraform destroy. The Terraform destroy is going to remove any of the resources that I've created. Now you can see here, it's saying that there's going to be 3 resources to be destroyed. And those 3 resources are the service account, the virtual machine, and also we're going to delete the firewall and that output variable. So I'm just going to answer yes to that. Terraform now is again interacting with the Google Cloud API, and it's going to clean up and delete that resource. It's a really nice way because anything that I define within my Terraform configuration, I just run a Terraform apply. And then, of course, I can clean up after myself with a destroy. And it's just a consistent way of always very quickly being able to get back to that known state. So for me, when I'm doing my experimentation, I don't need to worry about leaving those VMs hanging around for a long time and burning a little bit of cost. I can just spin them up and destroy them straight away, once I'm done with them. So that's done. We can see that the resources have been destroyed. Let's just pop over to the Cloud Console, and we should also see that resource has been removed there. So I'm just going to refresh my VM instances, and you can see, well, everything's gone. So the resource that we created, the virtual machine we created with Terraform, we've also removed with Terraform. And that's a nice thing about Terraform. It can manage that whole life cycle. Anything that I create, I don't need to worry about things that I'm clicking in the console that I've forgotten about. Terraform can clean up for me. Now let's see how we can provision an application to that virtual machine. And the application that we're going to provision, we're going to look at Open Web UI. So how are we going to go and provision our application? Well, what we're going to do is we're going to use a property here on our virtual machine called metadata startup script. And what metadata startup script allows us to do is to pass a script to the configuration. When the virtual machine is created, the script's going to execute, and any of the commands that are defined in it will also be executed. Let's have a look at our script. So the script that I'm going to run here is called provision basic, and it's just a bash script, and you can find this in the example repo. But let's just step through this and explain what's going on. So what we're going to do is we're first setting the set-e. So that means that if any command inside of the script fails, the entire script will fail. And then we're also setting non-interactive mode. So if any commands that we run require any sort of UI elements or anything like that, they'll kind of be bypassed. It's kind of running in headless mode. So the application that we want to install is Open Web UI. Let's have a look at Open Web UI. So Open Web UI allows you to run LLMs locally. So I can download an LLM from Ollama, and I can run it locally. So I can have my own local version. And that's really nice. So it's going to allow me to do a little bit of experimentation. I can do some sort of private RAG-based types of things where I'm interrogating my own personal documents. But what I can also do is I can interact with OpenAI. So I can use Open Web UI as an interface to OpenAI. And this is a kind of a nice example. I mean, you can install any application, but it's just a nice little tool that I quite enjoy using at the moment. So the recommended approach to running Open Web UI is to use Docker. So there's a Docker image which has Open Web UI and also has a bundled version of Ollama. And we're going to use this approach. So let's go back over to our script and we can kind of see what's going on. So because we want to run Docker containers, we need to install Docker. So we're going to do that. So this section of the script here is just installing Docker. It's installing Docker's GPG key, and it's adding its repo. And this comes straight from Docker's documentation. Then what I want to do is install Open Web UI. So I'm going to create a folder where I'm going to store the data for Open Web UI. Because a Docker container is by default immutable. So any file system manipulation that I make inside of that container, it'll be lost whenever the container restarts. So any changes that I make to Open Web UI will also be lost. A way around this is to mount a volume. So I can mount a volume inside the container to the file system on my virtual machine. And that's what I'm going to do. So I'm going to create that in etc. Open Web UI. Now, Open Web UI, whenever it starts by default, it doesn't have any user credentials configured. So if somebody else can manage to get to Open Web UI before I do, then they can configure the admin user for that. So to work around this, what we're going to do is we're going to pre-configure the administration user for Open Web UI so that when it starts, it's all safe and secure. So in order to generate those credentials, what we're going to do is we're going to start Open Web UI. That will create our database, and then we can add a record for our admin user to that database. And that kind of format is how it's recommended to change the admin user from the Open Web UI docs. So the password itself, well, the password itself needs to be in Apache format. So we're going to use htpassword to generate that. So again, let's just install a couple of tools. We need SQLite 3 so that we can interact with the Open Web UI SQLite database. And we need Apache 2 utils, which contains htpassword. Then what we're going to do is we're going to set two script variables, password and user. Now for the moment, I'm hard coding password and user, and we'll see in a little bit how we can make this more dynamic. But just note, this is not a good idea. You do not ever want to hard code credentials inside of any of your scripts. Use the capabilities that enable you to make them dynamic. But we will do that. So we're just setting those temporarily. Then what I'm going to do is I'm just going to pull the web UI container, and I'm getting the instance, which also has Ollama bundled in it. And then I'm just running it. And I'm running it, and all that does is runs that initial setup. It creates the SQLite database, which has the authentication and things like that in it. All of that takes a little while, so I've just got a little script here, and all I'm doing is just running that script, and I'm checking that as soon as the Open Web UI interface is available, then I know it's all up and created and everything's good. And as soon as that happens, I'm just cleaning up after myself and deleting it because I don't need it anymore. So to create my admin user, I'm going to update the Open Web UI database, and I'm updating the auth table and the user table to insert my user. So we're just going to write a SQL file that we're going to execute, and that's going to create our user, and it's going to update the users table and set that as an admin user. So everything will kind of pre-configure the auth for Open Web UI. And we're just doing that there. So we're just writing that out to a file. And then what we're doing is we're just using the SQLite command. We're executing that SQL file, and we're going to update those user databases. So once that's done, it means that the database has been pre-configured for Open Web UI. What I can do next is I can now configure that application to start whenever the virtual machine boots. And the way that I'm going to do that is I'm just going to create a systemd service. So again, here what you can see is a kind of very straightforward and basic systemd setup. So we're creating the systemd unit called Open Web UI. I'm making sure that this systemd unit runs after Docker because it has a dependency on Docker in order to work. And then we're setting some pre-commands for the start. And all I'm doing here is removing any existing web UI container, stopping it. And if you notice here, I'm using %n. It's just a simple syntax which allows me to grab the name for the systemd unit from inside the file. And why that's important is if I look at the exec start, then I'm doing that Docker run. I'm exposing port 80, which is mapped to the Open Web UI port 8080. I'm setting an environment variable there to automatically update RAG, and then setting some of those volumes. And the volumes that I'm setting is going to point to my pre-created auth database and also the data folder. And if I go to the very end of here, I'm going to specify a name for my Docker container. And again, I'm using that %n so that I can automatically grab the systemd unit name. So once we've written that systemd unit to disk, we then just run the daemon reload to reload it. We're going to enable that unit file, and then we're going to start it. So it's very standard Unix stuff. There's nothing special going on here. And actually, you could run any application you want. You could set up anything you need. You don't have to use Docker. You could be downloading a binary. You could set it up and install it. You don't even need to use systemd. However you want to configure that, you can do this. It's just a standard bash script, which I think makes it really, really accessible. So that's our script. Now let's add it to our virtual machine. Back over to the virtual machine resource. So I need to add an additional parameter, and that parameter is going to be metadata startup script. And then what we're going to do is we're going to specify the file. And the file that we're going to use is actually stored in scripts. And it's going to be provision basic.sh. So I'm using a relative path here. In order to ensure that I don't need to worry about relative paths, because I may run my apply from a different folder, what I can do is I can use an interpolation, which built into Terraform here, called path.module. And path.module is going to give me the absolute path of where I've run this script from, which means that I can then use that relative without having to worry about hard coding any paths. So that's that setup there. Everything is good. We need to make one more change, because now whenever I do my Terraform apply, Google Cloud does not wait for the init script to complete before it's going to tell me that my application is ready. So I'm going to get that completion back from Terraform, but my machine is potentially not ready yet because that init script hasn't completed. So how can we work around this? How can we ensure that we only get that kind of completion from Terraform once the virtual machine is up? A common way to do this, well, we're just going to do a health check. We're already spinning up an application in our VM, and that application has a web application. So let's just add a new resource to Terraform, and we'll see how we can block our Terraform from completing until everything is ready and up and healthy. So there's a couple of ways we could do this. Terraform can allow you to run commands as part of your Terraform apply, but that requires a particular command to be installed on the machine, and it might not be there. So we could run curl, but what if curl isn't installed? Then Terraform is going to fail. A way around this is to use a provider. So we're going to use the TerraCurl provider from my good friend DevOps Rob. And what that will allow us to do is to execute an HTTP call. We can check the result and the response. And then once that completes, then Terraform will complete. So it's a nice way to kind of do that health check. Actually, TerraCurl is really useful for doing all sorts of things like configuration or any areas of Terraform where there isn't a particular provider, but you do have an API. TerraCurl can be used as an escape hatch there. Let's do that anyway. So let's grab that provider, let's add it to our configuration, and then we can add our TerraCurl resource. Again, I'm clicking on the use provider block. I'm just going to grab the code there, and I'm going to add it to my config. So we're just pasting it into that required providers block. We've now got Google. We've also got TerraCurl. We can now add a TerraCurl resource to our config. So just at the bottom of my configuration there, this is where I'm going to add that resource. So we're creating a TerraCurl request, and I'm just calling it Open Web UI. So what the TerraCurl request is going to do is it's going to execute a GET request against this URL. And the URL that we're executing is going to be the public IP of our virtual machine. And we're going to wait for a response code of 200. So this resource will not be marked as complete until TerraCurl gets a 200 response from the URL there, for this GET request. This isn't going to work straight away because it's going to take some time for the virtual machine to start and install and then run Open Web UI. So to get around that, what we're doing is we're specifying the maximum number of retries the TerraCurl request will make before it fails. We're setting that to 120, and we're going to set the retry interval to 10 seconds. So in effect, what we're doing is we're going to wait a maximum of 20 minutes for our application to be up and running before we fail our Terraform or before we succeed. It's just a really useful way of doing any health checks whenever you need to wait for a virtual machine to be ready and available before you continue with something else. This is all configured. Well, I need to add one more resource, and that is that I need to add a new firewall in order to be able to say that, well, port 80 is also accessible. We had port 22, but we need to add port 80. So let's do that. So I'm just going to add that in here. Google Compute Firewall, HTTP, very similar to the TCP one we created for SSH, port 80, and we're specifying the target tag of HTTP. So I need to add that target tag again to my virtual machine. So just going up to tags, I'm also adding HTTP, and that's everything configured. We've got our virtual machine instance. We're going to configure our startup script, which is using our provision basic script here. We're setting up our firewall to allow port 80, and then we've added our new provider TerraCurl so that we can use the TerraCurl request to allow us to block until the virtual machine is up and the application is ready to serve traffic. Let's give this a run. Let's do that Terraform Init, Terraform apply, and we'll see this all in action. Now, because I added a new provider, I do need to run init again. So Terraform Init. And Terraform Init is going to detect that I have that new TerraCurl provider. I'm going to go and download it and everything exactly the same as we did when we created and set up the Google provider at the beginning of this video. Next thing, let's just run that apply. So Terraform apply. Terraform is going to read my configuration. It's going to check it, telling me that I'm going to add 5 resources. So let's just have a quick sanity check. Let's see what's going on there. We're going to create our TerraCurl request. We're creating our service account. We are creating our virtual machine here. We are then also going to set up our init script. You can see that there. And also our firewall. So everything is correct. This is exactly what we want. So I'm going to answer yes to that. Now we're going to have to wait. So we're going to wait for that virtual machine to be created. So Terraform is going to interact with the Google Cloud API. We're going to create the virtual machine. The virtual machine is then going to execute the init script. The init script is going to install Docker, download and install OpenWebUI, configure the authentication, and then Terraform is waiting there in the background and it's pinging the public port for OpenWebUI. And as soon as OpenWebUI is up and ready, then Terraform is going to complete. So you can see there, if you look at the output, that everything is being created. The Google Compute instance is being created. And if we go over to the console, you can see that there. That does not mean that the machine is ready to serve traffic, because it will take a little while for OpenWebUI to get installed and everything set up. So let's just wait for that to complete. As soon as it does, Terraform is going to give us the public IP and we can test out the application. So Terraform's completed, and that means the init script must have run and that OpenWebUI is up and running because Terraform has been able to successfully reach the endpoint. So let's grab the public IP and let's open it up in a browser and just check that everything is up and running. So we can see there that we've got the OpenWebUI interface is up and running, and that's on our public port. So we can just check this is working. So admin at demo.js, my password. We log in, we can see everything's working. So that authentication that we pre-configured inside of our init script has also worked. Let's look at this now. Let's make this more dynamic because we don't want to be hard coding that username. We don't want to be hard coding that password. And what I also want to be able to do is I want to be able to use the OpenAI API from OpenWebUI. So I need to pass my OpenAI key to it. So let's see now how we can make all of this configuration dynamic, how we can add all of those elements and how we can modify that init script so that it's dynamic every time that it runs and can provide all of those credentials. In order to make our configuration dynamic, we can introduce a new concept called a variable. So a variable allows us to define a placeholder for something which can then be injected and controlled whenever we run Terraform apply or Terraform plan. Let's have a look at this. So let's create a variable for our OpenWebUI administration user. So it looks like this. So we're defining variable. So we're using the keyword variable and then the name of the variable. And this is OpenWebUI user. So we can write a description, which makes our documentation for our code a little bit easier. And I'm just specifying this is the username for OpenWebUI. And then I can also optionally specify a default. So I'm setting the default here to admin at demo.js. If I don't specify a default, then what would happen is Terraform will prompt me to provide a value. And it'll do that whenever I run Terraform apply or Terraform plan. We can set that there. Now let's add two more variables. And the two other variables that I want to be able to add relate to the OpenAI credentials. So let's have a look at those. So I'm going to specify the OpenAI base and the OpenAI key. So the OpenAI base, I'm setting the default there, and I'm setting that to openai.com/v1, which is the default API for OpenAI's paid offering. Now I'm setting the key, and I'm just setting that to a blank string because I want to be able to determine whether it's kind of set or not. I don't want Terraform to always force me to set a value. So I'm just setting that to a blank value there. You can get an OpenAI key from OpenAI. It's very inexpensive, and it's actually a really useful tool when you're experimenting with any AI sort of stuff there. So this is kind of all we need to set. Now, we've mentioned that we don't want to be able to kind of hard code any value. So how do I specify the OpenAI key? Well, let's have a look. There's two ways that I can do it. One is using an environment variable, and the second is I can use a command line flag. Let's look at the command line flag first. If I run the command Terraform apply, what I can also do is I can specify the flag var. And var allows me to set any Terraform variables from the command line. So for example, I have this OpenAI key variable specified here. We can set that there by doing OpenAI key and then setting the value. So that's one way that we can kind of inject that variable into the Terraform code. Another way we can do it is by setting an environment variable using a specific convention. Let's have a look at this one. So I'm back over at my environment script. And what I'm going to do is I'm going to set an environment variable, but I'm calling it tf_var_OpenAI key. So the OpenAI key corresponds to the variable within Terraform. Now I'm prefixing it with this tf_var_. So whenever you run Terraform apply, Terraform is going to search for any environment variables which have this prefix, and it's going to attempt to set any Terraform variables which have the key which follow the prefix. So in this instance, if I have the environment variable set tf_var_open_key, what will happen is that Terraform variable OpenAPI, what will happen is the Terraform variable OpenAI_key will automatically get set whenever I run apply. Again, it's just a really nice way to keep the secrets out of Terraform, to be able to manage them externally, not to have to worry about hard coding them into your configuration where they could accidentally leak. If you're going to be using something like Terraform Cloud allows you to set these environment variables as well inside of your project or your workspace setup. So again, it's a really nice little concept. Let's get this going. Let's have a look at how we can now modify our init script, how we can use those dynamic sections, and how we can run our apply again and just make the whole configuration a little bit more dynamic. So we're going to go back over to our virtual machine. So in our virtual machine, we're setting the metadata startup script and we're using file. The file allows us to load a file from disk. There's also another function we can use, and this one is called template file. So let's just modify this, template file. Now, template file has two parameters. It has the name of the file, and it also has the variables. So let's add this. We're just going to add our variables here. So our variables are a list of variables that we can pass to the template, which we can then use to interpolate the various different values. The template file by default does not automatically pick up all of your Terraform variables. You've got to explicitly add those. So I'm going to add those there, and Copilot is actually doing a pretty good job of guessing exactly what I want to do. We've got that set up. Let's just add the missing comma there, and you can see what's going on. So we have template file, the path to our file, so provision basic. We're going to rename this actually. I'm going to use a new script because I want to create a dynamic script. So I'm calling this provision vars. And then I have the variables that I want to make available to that template. And those are going to be the OpenWebUI user, the OpenAI base, and the OpenAI key. Let's have a look at that provision vars. Let's now see how we can kind of modify it to make it dynamic. So at the moment, this vars script is just a copy of the basic one. We're going to go through, we're going to modify it to be able to make it more dynamic and to use those variables. Let's have a look. So the first area we want to change, we're going to just scroll down to where we were hard coding that username and password. So we can see here, we've got the password and we've got the username. Let's tackle the username first. So I'm going to replace that. And what I'm going to do is I'm going to use this $curly bracket. The $curly bracket is similar to what you've seen inside of the Terraform configuration. It's that interpolation escape. So I can now say, right, I want to use a variable that's available to the template. Those variables, let's just quick have a look. OpenWebUI user, OpenAI base, and OpenAI key. So let's use OpenWebUI user. I'm going to type that, OpenWebUI user. Then I close it with curly bracket. So whenever template file executes, it's going to replace the value of OpenWebUI user with whatever value that has. And that's going to be the same as the value that we're setting as our Terraform variable. So we want to also add a couple of little bits and pieces. We want to be able to add the OpenAI key and the OpenAI base. So let's add those. Let's see how we can do this. We're going to scroll down a little bit just before we do our systemd unit, and we're going to have a look at another feature of template file. So this feature is going to allow us to actually do conditional statements. So what I'm doing here is I've just added this block, and I'm now using this syntax here. So this syntax is %curly bracket. So this is for conditionals. I can do if statements, I can do loops, and all sorts of things like that on lists. So I'm saying if OpenAI key, so the variable OpenAI key that's passed to template file, if it's not empty, then I want to write an environment variable OpenAI key to the file, etc. OpenWebUI, OpenWebUI env. And I'm going to set that to be the value of OpenAI key. So we need to, again, just put that syntax in there, like so. And we need to put the syntax in there also for the OpenAI base. So the reason that I'm doing this is that I'm going to create an environment file. So systemd can load environment files. So I can create those environment variables that are going to be available to systemd, and they're going to configure the Docker run command. So it's actually going to set the OpenAI key and the OpenAI base on our Docker run. So we're going to set that up like that. Before we kind of dig any further, though, we need to look at something. Because now we're using template file, we're going to have some issues. Let's have a look at this line here where we're doing our SQL statement. And we're saying insert into auth values. Now, if you look, I'm using the bash variable syntax here of $curly bracket. Now, that's exactly the same as the template file variable syntax. So this will cause an error. If I run this now, it will tell me that the variable user doesn't exist because template file is trying to find a substitution called user. To escape this so that we can just use the standard bash variable, I'm just prefixing it with an additional $. And I'm going to do that for all of those there for user, password, and user. If we scroll a little bit further, you'll also see we have another problem. So again, line 44 here, what we're doing in our script where we're waiting for OpenWebUI to have started, we're using curl. Now, curl has the ability to define a template, so I can kind of specify that I just want to extract a particular part of the curl response, which I'm using for my comparison, and that particular part is HTTP code. It uses exactly the same syntax as the conditional syntax of template file. So again, what I can do, let me just double up those percentages. I'm going to escape that. Template file is not going to consider it as an internal, and it's going to allow me to just use the standard sort of curl template. So that's all good there. We've got that set up for OpenAI key. We've got the OpenAI base. We've got the username set up. Let's add those to our template. So I'm just going to go down to the systemd unit, and I'm going to use those environment variables. So let's add environment file, and we're going to specify the environment file that we just created. So when systemd unit starts, I'm going to load the environment variables from this file and make them available to the command. I can then specify those in my command here. So I'm going to specify OpenAI base, and I'm going to specify OpenAI key. Now, if you notice, I'm not doubling up the dollars here because I don't have to, because I'm not using the $curly bracket syntax. So it's absolutely fine. So when exec start runs, it's now going to do a Docker run, and it's also going to include the value of OpenAI base and OpenAI key if it's set. If we don't set those, that command will run absolutely fine. So we've made the template nice and dynamic. Let's save this. Let's give it a run. But before we do, let's address one last problem. And the last problem that we want to address is that hard-coded password. How are we going to solve this? Another Terraform provider. That's how we're going to solve it. Let's take a look at the random provider. So the random provider allows us to do, well, pretty much random things. We can do things like generate random bytes, generate random IDs, random integers, random passwords, and this is what we're interested in, and much more. But it is a really interesting provider, and it's going to be great for what we want to do for generating our passwords. So to create a random password, I'm just going to define a resource called random password. I can specify the length. I can determine whether I want to use special characters. And if I do want to use special characters, I can also specify an override to control which special characters are available. Let's add this to our configuration, and then let's update our template to use this. So I'm just going to add this to the top of my file. So I'm adding my random resource. So I'm creating my random password. I'm just going to call it password. That's the Terraform reference. And I'm just going to create 16 characters long, and I'm not going to use special characters. I'm just going to keep it nice and simple. So now let's add this to our template file. So we're just going to go back down to our template file. And again, we're going to add open, and it's web UI, this time password. And what we're going to do is we're going to reference random password, and the result is where we're going to have that password from. So we can set that up like this. back over to our provision vars, and let's replace my password with that open web UI password. And that's configured that there. Lastly, we need to create an output variable because now we don't know what that password is. So we can create that output variable, and we're going to go to our outputs. So we're going to just add that output variable, and I'm specifying it as sensitive. And why specifying it sensitive, what it means is whenever I run Terraform plan or apply, it will show me the public IP, it will not show me the password. And this is a nice way to ensuring that things like sensitive values like password don't leak into any logs or anything like that. I can still get the value by explicitly calling Terraform output password, and we'll see this in a moment, but as a kind of a standard approach, it's going to be masked. So this is exactly what we want. So that's all done. Now let's run it. Let's create our VM, and then let's log in and have a play. So we've added a new provider. So Terraform Init. That's going to download the new random provider and install that locally for us. And now we've got that. What we can do is run our Terraform apply. So running Terraform apply, that's going to check our configuration. It's telling me here that I'm forcing a replacement. Let's have a look at this. So it's adding 3 resources and it's going to destroy 2. Let's have a look, see what is going on. So first things first, we can see that we're going to replace the Open Web UI instance. Now, why is this? The reason this is going to get replaced is that we've changed our init script. We've changed that metadata. So you can see here that Terraform is informing us that because the metadata startup script has changed, it's going to force a replacement of the virtual machine. The virtual machine will be destroyed. It will then be recreated so that new startup script can run. And that's exactly how the documentation told us earlier on. This is great. And then we can scroll down a little bit further. We can see, well, just setting up that new virtual machine, all of those settings there. We can see our new password, which is going to be created. And then TerraCurl is also going to get replaced. So Terraform is smart enough to realize that because the virtual machine resource is being replaced, it needs to also replace any resources which are dependent on it. Because we're referencing the IP address from the virtual machine inside of TerraCurl, Terraform's smart enough to know that, well, I need to then rerun that TerraCurl request because the IP address has changed. So all this is good. I'm going to answer yes. We're just going to kind of sit and wait whilst Terraform does its business, deletes that old virtual machine, creates the new one, provisions it. Then we're going to log in and we're going to have a play with Open Web UI. Okay, so this is completed. Let's grab that IP address and now let's log in. Grab that IP there and I'm just going to open this up in my browser. So we got the Open Web UI login page. Let's log in with our username, which is admin@demo.js. And then our password, we need to grab this from Terraform. So I'm going to do Terraform output password. And then I'm just going to grab that, copy this, paste it in there, and then we're going to sign it. So this is great. Everything is working as expected. So if we now look at the models, well, because we've configured those OpenAI credentials, we've now hooked up Open Web UI to use OpenAI's API. So we can use all of the LLMs that are available there. So let's choose one of these. Let's just use GPT-4. Now let's ask GPT a question. Let's ask it a question about the different types of variables that can be used in Terraform. Can you use different types for Terraform variables? And we'll see what it's got to say. So it says that Terraform allows you to specify the type of the variables in your configuration. These include string, number, Boolean, list, map, etc. Okay, this is interesting. So let's ask it again about map types. What are map variable types in Terraform? So it says that we can actually specify a variable as a key value. So we can set a more sort of complex type than just the basic strings that we've been using so far. So I could specify here the image ID, and I could specify the default value, and I can set it as a map. So I can have these different keys and these different values. Let's see how we can use this to make another change to our application. now is to be able to configure either using a CPU type of virtual machine or a GPU-enabled virtual machine. If we use a GPU-enabled virtual machine, then we can run our LLMs locally rather than having to use OpenAI. Let's set this up. Let's have a look at those complex variables. Let's look at some of the conditional statements that we can use within Terraform, and then let's kind of finish up our project. So I'm back over at my main TF file. Let's add that complex variable, and we're going to call this one machine. Now, what machine is going to do is machine's going to allow us to configure the different types for our virtual machine. So I'm going to define this as a map, and I'm going to have two keys, GPU and CPU. Now, each of those can also be a map. So we have GPU and it has type, and then we can determine that we're going to use a GPU-enabled virtual machine. Now, what we can also do here is we're going to use a different base image. Because if we're using a GPU-enabled virtual machine, we want to use a base image which has already got some software installed like the NVIDIA drivers. And to do that, we can use some of those images that Google have already provided for us. Then we're going to use this one here. We're going to use one of their data science images, which has Python and it's got some of the various other different bits and pieces. If we're using CPU, well, we're just going to continue to use that same standard N4 image. If we're using CPU, we're just going to use that standard image and we're still going to use Debian Cloud. So that'll work there. Now, in order to select between those, let's add one more variable. And the variable that we're going to add now is going to allow us to switch between those. So we're going to have this variable, which is a Boolean type, and it's going to be called GPU enabled. If I have the GPU enabled set to true, then what I want to do is I want to use the properties from this variable machine, the GPU map type. So let's have a look at how we can do that, how we can write a conditional statement in Terraform. And I'm first going to go up to my data source. I want to replace these hard-coded values here where I've got Debian 11 and Debian Cloud, and I want to replace those with my new types. So what I can say is I can say, well, okay, so var GPU enabled. I can use some special syntax here, and I can use this syntax here where I have a question mark. So if GPU enabled is true, I can have a value. So AB, for example, let's just put some placeholders in. If it's false, we can have a different value. Now what I can do is I can replace that with my new map variable. So I'm going to say var.machine, and then I'm going to select the GPU key from the machine, and then I can select another key, which is going to be the family. So we're setting that up like this. So I'm now saying that if GPU is enabled, it's going to be true, then use the family value from the GPU key of the machine variable. If it isn't, if it's false, then what we can do is we can just say var.machine.cpu.family. Now, we can do exactly the same for the project. So we're just going to say var.gpu enabled, and well, Copilot has already figured that out for me, but that's exactly what I want. So I've now got this conditional statement where I can use a complex variable dependent on a sort of a simple variable. We need to make one more change here as well. We need to also add the machine type. So I'm, again, just going to say if GPU enabled, then I want to specify a GPU machine type. If it's not, then I'm just going to use the standard CPU type. This is good. Lastly, now let's update our template. So I'm just going to go down here and I'm adding an additional key here, and I'm just going to say GPU enabled and setting that there. So now what we can do is we can do some additional setup stuff if we're using a GPU enabled machine. What we need to do there is we just need to install some NVIDIA drivers and we need to install the NVIDIA container toolkit. So let's do that. Let's update that script, and then we can reapply this and then test this out running a local version of Olama. So I'm just going to scroll down here and I'm going to add another conditional. And the conditional that I'm going to add this time is just going to be based on GPU enabled. So if GPU enabled is set to true, then what I'm going to do is I'm going to set the GPU flag, which tells Docker that it should be using the GPU devices. And that's using this flag here that you specify to Docker run. We're just writing that to that same systemd environment file that we did for the OpenAI key in base. Then what we're going to do is we're going to install the NVIDIA container toolkit. Now we only need to do this when we're using a GPU enabled virtual machine. So we're just grabbing that, we're setting that up from the NVIDIA documentation, and we're going to update that, install the container toolkit, and then we're going to configure Docker to be able to use NVIDIA GPUs. Finally, what we're going to do is we're going to install the NVIDIA drivers for Linux. Now, these have already been added to the repository, and they're already partially configured using these Google Deep Learning images, but we do need to actually finalize the setup. And to finalize the setup, again, we're just going to run this install driver script, which is in opt deep learning, and that's already been pre-configured as part of the Google virtual machine image. That's all good. Finally, very last thing, we just need to add our GPU flag to our Docker run command. Everything is good here. And we're changing this to reboot because unlike just starting the Open Web UI service, after we've installed the NVIDIA driver, we need to reboot the virtual machine. Okay, so let's create that configuration again. So I'm going to do Terraform apply, and I'm specifying var GPU enabled equals true. And that's going to switch to use the GPU enabled virtual machine. We can see here that we've got 2 new items to add, 2 to destroy, forcing that replacement. And that's because we're changing, obviously, the virtual machine type. And we're also changing the metadata script. So those 2 things will force that replacement. And you can kind of see those things there. The image is also changing. Let's do that. Let's hit yes. Let's wait for that to finish. Take just a couple of minutes, and we're going to log in and play with that LLM. But now we're going to use a local version. Now that applies failed. And the reason that it's failed is because Terraform's giving me an error message. So it's saying here that instances with guest accelerators do not support live migration. So when we've applied that configuration, even though the configuration was valid, when it's hit the Google API, Google has determined that there's something missing, that something needs to be changed. And that change is that we can't have live migration. So we can set another block inside of Terraform. Let's go back to our resource. And what we need to do is we just need to make an update and set something in the scheduling block. So scheduling, just another block here. And we're going to set on host maintenance to terminate. And this means that whenever we want to do any maintenance, the virtual machine will be automatically terminated and recreated by Google. It's not going to try and do any in-place updates. And that's required for GPU resources. So we're just going to set that block. We'll reapply this, and then everything should be good. So that GPU-enabled machine is now created, and we've just logged in there to Open Web UI. Now, we're not going to use any of these models. What we're going to use this time is we're going to use Mistral. And we're going to pull Mistral from olama.com. So we're going to run the LLM locally on this GPU-enabled virtual machine. So it's just going to take a second or 2 to download Mistral from Olama and then get that installed so we can then ask it some questions and see how it compares to GPT-4. Okay, so Mistral's been downloaded. Let's select that. We're going to choose that there. Let's ask it a question. Let's ask, how do I clean up Terraform resources? And we'll see what it's got to say for itself. So it says, cleaning up Terraform resources involves destroying the infrastructure that's created. And it tells me how I can find out what resources I've got by using the Terraform state command. But ultimately also it's telling me that I can just use that Terraform destroy command. And that's pretty awesome. So that's all running locally. So I've created that virtual machine and I've made a GPU enabled one. You know, I'm just using Open Web UI to kind of play around here, but I could use the same technique if I wanted to just run some Python script. Maybe I want to create a virtual machine where I can train an AI model and I want to use something which has more horsepower than I've got available on my desktop. Or maybe I'm using a Mac and I don't have a GPU on that. I want to use something which has an external NVIDIA GPU. All of these techniques that you've seen can be used to do that. But for now, let's run that Terraform destroy. Let's clean up our resources. Let's save a little bit of money. And then let's look at a little bit of a summary of what we've learned in this video. That's it. Virtual machine is gone. Everything's been cleaned up. Let's have a quick summary. So what we've learned how to register providers in Terraform. We've learned that by adding the required provider block, we can ensure that the plugin that's downloaded matches the configuration that you're writing. And we've learned that It's an important thing to do that, but always try to keep the provider to the latest version, because if you keep the provider on the latest version, all of the latest features are going to be there, all the latest bugs are going to be squashed, and it's a much better experience. So we'll do that. Now, we've learned that configuring the provider can be done through the provider block, but we can also configure it through environment variables. So we've configured all of the authentication for the Google provider, and we've done that through environment variables. And you've also seen where you can get the credentials for so that you can use them with Terraform by creating that service account. We've had a look at variables. We've seen that we can use variables to make Terraform configuration dynamic. And we've seen that we can use simple variables like strings, but we can also use more complex variables like maps and even Boolean values. We've seen that we can define those resources. We can define our resources, we can link them together, we can use data sources to be able to have read views on certain APIs in the cloud that we're using. And we've seen how to provision an application to be able to use Cloud Init scripts to be able to do something useful with our virtual machine. You've also seen output variables. We've seen how we can define an output variable and how that can be used from the Terraform CLI, either just by having that information available to you at the end of an apply command, or by using the Terraform output command to be able to do things like write subshells, fetch passwords, and all sorts of really useful things. And we've had a very brief introduction to functions. We've used two. We've used file to load our SSH key. We've used template file to be able to create our dynamic init script. But there are so many more functions inside of Terraform. There's a huge number of them. String functions, network block manipulation functions, all sorts of really useful things. So I really encourage you to go around and try that. And that's it. Well, for now, there's so much more with Terraform. You can create modules, you can create reusable components. There are so many other different providers and so many other resources within the Google provider. I really sort of encourage you to have a play around, experiment and create some interesting things. But that's all for this video. I hope to see you again. I hope you've enjoyed this, and I hope you've enjoyed learning some Terraform.